Hello teammates, it's Mr. Nanini coming to you with another physics bunker production. I apologize for posting this late. I had some serious allergies all weekend and I shot a video for AP Physics 1. I sniffled all the way through it. I didn't think you needed to put up with that. So here we go. I'm going to call this FRQ number 2. I'm going to tighten up how I'm labeling things on the YouTube and on my IP Classroom. You've read it already. You're given a mass of the raft, mass of a steel cube. You're given the dimensions of the cube. Caution always, meters, kilograms, seconds. You're going to convert that to meters. Do that right away. You're given the density of water. That's the typical density of fresh water. That's something to have in your head. I don't think they're going to expect you to memorize that. In normal years, they kind of do. But I don't know. You can have that handy. You put it. Students are put on a raft. I'm going to assume this is it's a pool. They tell us that. Actually, I don't have to assume that. They put it in, it slides off, those silly students, sinks to the bottom of the pool. You're going to figure out, does the pool level stay the same, rise, or fall? So think, there's a trap there, isn't there? There's a trap. If you put more into the pool, the trap is you think the water rises, but you know better than that. Tell you the bottom of the pool is 5 meters below the surface. I think drawing a quick picture to help you visualize. And you'll see in my solution that I've done that. And I think as you go through it, just, again, your brain only processes 30 bits a second. You want to free up that processing power. You keep a picture. You're going to lift it up. You're going to draw a free body diagram. And part 3, you're going to, B3, you're going to determine the tension force. So let's take a look at the solution. And here's how I did it. Now, I didn't draw, they want a paragraph length response for this. I thought it's better to show you my thought process. Every one of my teammates can write. But detail again, and I caution, I don't know, maybe I should have been more beastly on this through the year. Sometimes when I ask for a paragraph length response, I get like maybe a couple sentences. That's not, College Board doesn't, when they say paragraph, they mean a complete paragraph that identifies all your thoughts. So I've given you the benefit of the doubt. If I could tell you know what you're doing, College Board isn't going to do that. They don't know you. So paragraph means paragraph. So I broke it down, and you can certainly do this. If you've got enough time, you could certainly draw this. So I drew to help you visualize. I got the raft with the block. I got a total mass, the block and the raft, 930 kilograms. I drew a quick free body diagram. And then I showed that when the block falls to the bottom of the pool, it's going to displace its volume of water. Up here, it's going to displace a volume of water equal to its mass. Here, because it's floating, and we know that force gravity equals force buoy. Here, the block is going to displace its volume in water, not its mass. Recall that your equation for force buoyancy is rho vg. So this is still going to displace the volume of its mass. This is going to displace its volume in water, much smaller. So you're actually, I'll kind of lead the witness. Your water level is going to rise. So one point for identifying, this is in your paragraph again, for identifying these relationships that initially the water displaced is going to be the mass, equal to the mass. And the second place that the block is going to displace the volume in water. those are 2 points. I think whenever you can draw a free body diagram, draw a free body diagram. Even in a paragraph length response, draw a free body diagram. And so volume of water displaced is less than the volume of water displaced in the initial state. And you can demonstrate this. It didn't ask you to demonstrate this. I went ahead and did it. So the initial condition, force buoyancy, is so you know you got balanced forces, force buoyancy up. So I know force buoyancy must be balanced with my mg, so I'm going to solve for my force buoyancy. 9,300 newtons is my force buoyant, divided by density of water times g. I get 0.93 meter cubic meters displaced. Final condition, you're gonna the raft is 200 kilograms, so 2,000 newtons force buoyancy up. You got 2,000 newtons down, you got 2,000 up. You're going to solve 0.2 meters cubed. And then you're going to look at the volume of the block. The block's going to displace its volume in water. Be cautious here. Be really cautious because you're doing 0.45 meters on a side. You're not doing 0.45 times 3. That's going to give you the wrong answer. That's the trap too. 0.4, so a cubic meter, you got a cube, 0.45 times 0.45 times 0.45 or 0.45 cubed. You're going to get a volume of 0.091 cubic meters. 0.2 times 0.091, 0.291 cubic meters. And so to hit in your paragraph length response, the volume displaced is going to decrease in the y is a point as well. So comparing what your initial volume would be to your final volume, those are each 1 point. Now, do you have to calculate? I don't think so, but I think you've got to have a reason. You just can't say something like, well, obviously that more water is going to be displaced when the cube is on the raft. You got to put some detail on it. You got to talk about force buoyancy and volumes. You can't just, right? You got to defend every statement. You just can't say, well, obviously, you would never do that. Therefore, volume displaced, initial condition, much less, so that the level of the pool falls, right? So you put this thing in the water, you put it in the water, your pool level is going to rise. That block falls off, it's going to displace its volume of water, that level falls. It's good? I hope so. Let's BI. Predict how the force exerted by the crane at 2 meters compares to 4. So here's at our level, first year physics. You're going to work with this force buoyancy, density times volume times acceleration due to gravity. There's no dependence there on depth. Tie back to your controlling equation and then move forward from there. Now, in real life, IRL, does the density of water change with depth? It does, right? Because you got all that water molecule pushing on. Just like the density of the air decreases as you go up in our atmosphere, the density of the water decreases as you go up. But we're not going to have to tackle that. We could. It's not part of our program. It'd be minuscule. Minuscule. So the key point there is there's no dependence. Go back to your controlling equation. Because the unwashed mass will say, well, of course, I go to the bottom of the pool, I feel more pressure. Well, that's true. But it's not relevant to this question. That's 1 point. BI was 1 point. You're going to then draw a free body diagram. And let me show you. I drew it here so I can show you on this. Here's the key here. Always label forces An unlabeled force is liable to give you 0 points. Always label your forces. So what you want to show, you're moving it up a constant velocity, so you know there's no acceleration, so you know the forces are balanced. Draw a vector length, force gravity. Draw a vector force buoyancy. We've kind of established there's not a lot of buoyant force for that block, and I would make the rest force tension. The key is that you got 1, 2, 3 blocks up, 1, 2, 3 blocks down. Your forces are balanced. You can stack forces like that. Another way to draw it, you could draw, I'm just going to freehand it. Force gravity, force buoy, force tension. You could draw it like that. And that'll do the same. Every independent force gets its own vector. Hot diggity dog. That was, they scored it interestingly. Showing force buoyancy up, force gravity down was a point. Showing force tension at these forces balance this force was a point as well. Kind of squirrely to me, but just draw a complete free body diagram. Easy money. Leave no points on the table. Last one. Rounding third, headed for home. You're asked to calculate the force tension. I actually started up here. That's my mistake. I get excited because I said, I wonder what the relation is. Start here. Start with your relationship. In this case, you know the forces are balanced. Force tension plus force buoyancy equals your force gravity. Start there. That's 1 point. Just identify this relationship. Rearrange your variables to solve for force tension. Keep it like that. Then put in your variables. Then put in your numbers. If you're asked to calculate, follow that pattern. On exam day, you're going to hear my voice in your head telling you that. Listen to it. Start with your relationship. Isolate your variable, your unknown. Put in your variables. Put in your numbers. Solve. Answer. 2 points for that. Right? Follow that process. Nobody cares. If you write 6390, they don't care. They want to see this. It's good. You got to show your work. Especially on this exam. Especially on this, hopefully one time only AP exam. If you just pop in with an answer, all magical like that, you are not only probably not going to get credit, they're probably going to investigate you for cheating. So let's not do that. Hot dog teammates, keep them cards and letters coming. I'm going to post this and have a great day.